Now we shall continue the exercise 5A and its solutions. But before we will do two important concepts, then we will continue the exercise 5A. So the first important concept is related to we will find out the range of k so that the polynomial equation or algebraic equation has real and unequal roots. So for real and unequal roots, so we'll start with the help of one important question. The question is find the values of k for which the equation for which the equation x to the power 4 plus 4x cube minus 2x square minus 12x plus k equals to 0 has 4 real and unequal roots. Real and unequal roots. For real and the equation, degree of the equation is 4. So obviously by fundamental theorem we can say this equation has 4 roots. It may be real or complex, but here the question is related to for what range of k all the roots must be real and unequal. So how to solve this kind of problem, and you will find out the range of k. Let's fx, we just consider the polynomial as a function fx, x to the power 4 plus 4x cube minus 2x square minus 12x plus k. This is our fx. Now we need to determine the values of k for which this equation fx equals to 0 has 4 real and unequal roots. So next you need to decide what is your f dash x. So here the step 1, the working procedure. Step 1, write fx and f dash x. So f dash x equals to 4x cube plus 12x square minus 4x minus 12. So in that case, you can eliminate the k because d dx of any constant is 0. So now this is a cubic equation. So we can write it as a factor with the help of vanishing method. So that we can write 4 into x minus 1 into x plus 3 into x plus 1. So our step 2 is write f dash x as f dash x equals to some constant multiple x minus alpha 1, x minus alpha 2 and x minus alpha k. Now you need to find out step 3, the roots of f dash x. So here the roots of f dash x equals to 0 are minus 3, minus 1 and 1. So you just here calculate f dash equals to 0 and you will get x equals to alpha 1, alpha 2 and alpha k. Now you need to observe, there should be an observation. Step 4, all roots of the equation, all roots are real and distinct of f dash x. If yes, then we will continue step 5. So now since the roots of the equation f dash x equals to 0 are real and distinct, are real and distinct of f dash x. This is exactly given. The roots are, four roots are real or distinct. So they will be separated by the roots of the equation, the roots of the equation f dash x equals to 0. So here you will write, since roots of fx equals to 0 are real and distinct, so they will be separated by the roots of f dash x equals to 0. Now you just observe what are the roots. What are the roots of f dash x equals to 0? The roots are -3, -1 and 1. So here f dash x has 3 roots and they will be separated by the root of fx equals to 0. The root of fx equals to 0 separated by the roots of f dash x equals to 0. So one root lies between -infinity to 3 and other root lies between -3 to -1. One is lies between -1 to 1 and the fourth one is lies between 1 to infinity. That we need to write. So the next step is, therefore, one root is less than -3. One root lies between -3 and -1. One root lies between -1 and 1, and one root lies between 1 and infinity. So here step 6, you will write one root lies between -infinity to and alpha 1, then alpha 1 to alpha 2, and one lies between alpha k and infinity. So therefore, you just observe now what is f of -infinity. So this is -infinity, -3, -1, 1 and infinity. So one root lies between this, another root lies between this and this. So these are the four roots. You need to calculate f of -infinity, and that will be positive. F of -3, that will be -9 plus k, as your fx equals to x to the power 4 plus 4x cube minus 2x square minus 12x plus k. So f of -3, f of -1 is basically 7 plus k, f of 1 -9 plus k, and f of infinity again greater than 0. Now, since one root lies between or is less than -3. So if f of minus infinity greater than 0, so that means that will be f of -3 will be less than 0. So f of -3 and f of minus infinity greater than 0, that implies f of -3 is less than 0. That means here -9 plus k less than 0, and that implies k less than 9. This is 1. Again, since one root lies between -3 and -1, and f of -3 is less than 0, that means f of -1 is greater than 0. So that means 7 plus k greater than 0, so k greater than -7, this is 2. Again, since one root lies between 1 and 3, and f of -1 and 1, and f of -1 greater than 0, that implies f of 1 less than 0. That means -9 plus k less than 0. So that means k is here, k is less than 9. K is less than 9. This is 3. So from 1, therefore from 1, 2 and 3, we get -7 less than k less than 9. So this is the values of k for which all roots are real and distinct. So this kind of question has been asked in different competitive examination as well as the graduation course, where theory of equation is described as a syllabus. Now we come to the same problem, but it is given as MCQ for what values of k for which the algebraic equation x to the power 4 plus 4x cube minus 2x square minus 12x plus k equals to 0 has 4 real and distinct roots. Option A, k is less than -7. Option B, -7 less than k less than 9. Option C, k greater than 9. And option D, for all k belongs to real number. So option B is correct. All other options are false. So now you have given exercise, the homework. You will solve it easily in the same way. The question is show that the equation x to the power 4 minus 14x square plus 24x plus k equals to 0. Exactly in similar way you can prove it, has 4 real and unequal roots if -11 less than k less than -8. So this exercise is given page 210 इसके mapa book classical algebra problem number 21. Problem number 21. You can solve it in similar way, exactly in similar way. Now, based on this, the MCQ question may be the values of A for which the equation x to the power 4 plus 4x cube minus 2x square minus 12x plus k equals to 0 has 4 real and unequal roots is option A, k is less than minus 11, option B, minus 11 less than k less than minus 8, option C, minus 11 less than k less than 8, and option D, k is greater than minus 8. So option B is correct, all other options are false. So these two questions are also important. Now we come to another important recall. Recall for integer roots of an equation. Integer roots of an algebraic equation. How to find out the all integer root of the equation? The result is let fx equals to a0 x to the power n plus a1 x to the power n minus 1 plus an minus 1x plus an, that is belongs to zx, that means all coefficient are integer, be a polynomial with integer coefficient, that means polynomial with integer coefficient. Now if p by q be a rational root of the equation fx equals to 0, where GCD of p and q equals to 1, that means these rational roots, the denominator and the numerator, they are prime to each other, p and q. Then p is a divisor of n, that means p divides n, the constant term, and q divides the leading coefficient a0, and p minus q that divides f1, while p plus q that divides f of minus 1. So this recall is helpful to find out the integer roots of an algebraic equation, a polynomial equation with integer coefficient. So here is the problem. This problem is also important. The problem says that find all integer roots of the equation, x to the power 4 plus x cube minus 2x square plus 4x minus 24 equals to 0, and solve it. That means after finding integer roots, you will solve the problem. That means you will find out all the roots. So now the question is, what are the integer roots of the equation? that we need to determine first, then we will find out all the roots of the equation. That means solution. So here let fx equals to x to the power 4 plus x cube minus 2x square plus 4x minus 24. So then you need to calculate what is f1, because f1 and f1 minus 1 you will see here. So what is f1? So you will calculate f1 is minus 20. Just put x equals to 1 here, and f1 minus 1. This is minus 30. So now we consider let p be an integer root of the equation. P be an okay. So before that we need to write one corollary. This is also important. If q equals to 1, so p will be here the p by q rational root, but if you take q equals to 1, so p will be the integer root. So take q equals to 1, because we need to find out the integer root. So that means let fx equals to a0 x to the power a1 x to the power n minus 1 plus a n, this belongs to zx, polynomial with integer coefficient. If q equals to 1, p be an integer root of fx equals to 0. Now we'll have GCD of p and 1, that will be 1. Then by the recall we can say p divides an. 1 divides a0, that is not required, and 2 p minus 1, this divides f1, and a q value is 1, so p plus 1 is also divides f1 minus 1. So from this result we just consider p be an integer root of fx equals to 0. We consider this, so by the above corollary we can say then p divides n. N means the constant term. Here the constant term is minus 24. So p divides minus 24. So that implies what are the possibility of p? P may be plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, plus minus 8, plus minus 12, and plus minus 24. So these are the possibility, because since these are the divisors, they are divisors of 24, or you can say minus 24. Now since f1, what is f1? F1 is minus 20, that is non-zero, and f of minus 1, this is minus 30, this is also non-zero. So it follows that p not equals to 1, integer root, that means fp must be 0. So it follows that p1 f of minus 1, so p not equals to plus minus 1. So here we can discard, okay, this is not valid. Now what about the remaining divisors? That we can conclude from this result to p minus 1 divides f1. So again, since p minus 1 divides f1, what is f1 here? f1 is our minus 20. So this is minus 20. So therefore, and from that we can say p is not equals to minus 2, 4 minus 6, 8 minus 8, 12 and minus 12, 24 and minus 24. Because if we take p equals to minus 2 here, so minus 2 minus 3, minus 3, that does not divide minus 20. We'll check. Again, p plus 1. This is a divisor of a power minus 1. So what is a power minus 1? This is 30. Minus 30. From that you can conclude p is not equals to 3 and 6. 3 and 6. So therefore from this table, so 2 is the possibility maybe, minus 2 is not possible, plus 3 is not possible, minus 3 is possible. So from this result, so that we can consider 1, this is star, 2 and 3. We say what are the possible values of p. So the only possible values of p are, so here these are the possible values. The possible values of p are the possibility. So possible values of p are 2, minus 3 and minus 4. That we can say by 1, 2 and 3. Again, we just check f of 2, this is equals to 0. F of minus 3 is also 0, but f of minus 4, this is non-zero. So that means the possibility of p are 2 and minus 3. So minus 4 here discarded because minus 4 is not a root, that you will check. So these are the two integer roots. So therefore the integer roots of x to the power 4 plus x cube minus 2x square plus 4x minus 24 equals to 0 are 2 and minus 3. So these are the only two integer roots. One is 2 and other one is minus 3. Now we need to, the equation is of degree 4. That means it is 4 root. So 2 root are integer. That is, we need to determine again 2 other root. So how to determine? Okay. This is the first part. Now we move to the second part of the problem. The first part. Now we solve it. That means we need to find out all the roots. So 2 roots are integer. Since p equals to 2 and minus 3 are the integer roots of 1 of fx equals to 0. That means x minus 2 into x plus 3 is a factor. By factor theorem, factor of fx equals to x to the power 4 plus x cube minus 2x square plus 4x minus 24. So that implies by division algorithm, fx can be written as x minus 2 into x plus 3 into qx, because of factor, so remainder must be 0. So now we need to decide the qx. So qx will be fx by x minus 2 into x minus 3. What is our fx? X to the power 4 plus x cube minus 2x square plus 4x minus 24 by x minus 2 into x minus 3. So that x minus 2 into x minus 3, remaining part is x square by plus 4 by x minus 2 into x minus 3. So that is cancel out. So x square plus 4. So now the qx equals to 0 gives us x square plus 4 equals to 0, and that gives us x equals to plus minus 2i. This is the other two root. Therefore, roots of the equation fx equals to 0 of the given equation are 2, minus 3, 2i and minus 2i. So these are the four roots. So the solution is done. Now we'll move to the exercise. So exercise 5a, mapa, book, classical algebra. What is the page? Page is 208. That may be changed in your book, but okay. Now we'll continue from the first problem. Problem number 1. What is given? If alpha, beta, gamma, delta be the roots of the equation x to the power 4 minus x cube plus 2x square plus x plus 1 equals to 0, then find the value of Roman 1 alpha plus 1 into beta plus 1 into gamma plus 1 into delta plus 1. 2. Find the value of 2 alpha plus 1, 2 beta plus 1, 2 gamma plus 1 and 2 delta plus 1. 3. Alpha square plus 1, beta square plus 1, gamma square plus 1 into delta square plus 1. And 4. Alpha cube plus 1, beta cube plus 1, gamma cube plus 1 and delta cube plus 1. Now we need to solve the problem. So how to solve? Solution. So all this problem is very important. So here how to solve it? Since alpha, beta, delta are the roots of the equation x to the power 4 minus x cube plus 2x square plus x plus 1 equals to 0. So that equation can be written as x minus alpha into x minus beta. That will be the factor. They are the different factors. So x minus alpha, x minus gamma, x minus delta. So degree is 4 roots are there. So this is an identity. So this is an identity in X. Now we come to the problem. We will find out the value of alpha plus 1 and beta plus 1 and gamma plus 1 and delta plus 1. That product value. Now the simple thing is how these will be alpha plus 1, beta plus 1, gamma plus 1. Just you take one factor. So here the trick is for the first one. So alpha plus 1, that you think about x minus alpha. So what is your x? What is your x? Here your x will be x will be, if you think about like this, minus of x minus x plus alpha. In position of minus x, you will take 1. So minus 1. If we put x 1, so that will be, if we put minus 1, it will be minus alpha minus 1, and put x equals to minus 1, here it will be minus 1. If you take minus common, it will be alpha plus 1. So for 1, putting x equals to minus 1 in the identity, what we get? We get minus 1 whole to the power 4 minus 1 whole cube 2 into minus 1 whole square plus minus 1 1. So minus 1 minus alpha, minus 1 minus beta, minus 1 minus gamma, minus 1 minus delta. You take minus common on the right hand side, there will be 4 minus, so that will be minus 1 whole to the power 4, it will be plus. So from that you will calculate alpha plus 1 into beta plus 1 into gamma plus 1 into delta plus 1. That value will be 4. So this is the first problem that you can solve it. Next, 2 alpha plus 1. So how this will be 2 alpha plus 1? Put x equals to minus half and take common half, minus half from both sides. Take common minus, so it will be 2 alpha plus 1. Okay. So how x minus alpha will be 2 alpha plus 1. So here you put x equals to minus half and you will see this term. Maybe some constant will be multiple, but okay, you will see 2 alpha plus 1. So this is the trick that you need to follow. So to putting x equals to minus half in 1, or you can say star, it's an identity on the both sides. What we get? We get minus half whole to the power 4 minus half whole cube plus 2 into minus half whole square plus minus half plus 1. That will be the left hand side, this one. Right hand side, minus half minus alpha minus half minus beta minus half minus gamma minus half minus delta. So from that you will see 2 alpha plus 1, 2 beta plus 1, 2 gamma plus 1, 2 delta plus 1. That value will be 19. Okay, next 3. Here you will, the trick for here you will see how alpha square plus 1 will occur. So from x minus alpha, how alpha square plus 1 will be occur. You just here you just think about, okay, 2 alpha plus 1 equals to 0. That means you need to put in position of x minus half. Here you will think alpha plus 1 equals to 0. Then alpha equals to minus 1. You need to put x equals to minus 1. Similarly, here you will take alpha square plus 1 equals to 0. It's a rough trick. So alpha equals to plus minus I. That means you need to put 1 x equals to I, then x equals to minus I. After that you will multiply in the same way. So now putting x equals to I in star on the both side, what we will get? We will get I to the power 4 minus I cube plus 2I square plus I plus 1. So this is equals to I minus alpha, I minus beta, I minus gamma, I minus delta. Okay, that means here you get alpha minus I into beta minus I into gamma minus I into delta minus I. So this is equals to 2I. So that you can think about, okay, that this is your double star. Again, putting x equals to minus I in single star, what we get? We get minus I whole to the power 4 minus I whole cube 2 into minus I whole square minus I plus 1. This is equals to minus I minus alpha minus I minus beta minus I minus gamma minus I minus delta. So from this information you will get alpha plus I, beta plus I, gamma plus I into delta plus I. This will be your minus 2I. So this is triple star. Now we multiple now by multiplying double star and triple star. What we get? We get on the left side alpha square plus 1, beta square plus 1, gamma square plus 1 and delta square plus 1. Because alpha minus I into alpha plus I, that will be alpha square plus 1. So this is 2I multiple minus 2I. So that means minus 4I square. So that means 4. So therefore the value of alpha square plus 1, beta square plus 1, gamma square plus 1 and delta square plus 1. Now we come to the problem 4 here. So just to think alpha cube plus 1 equals to 0. That means alpha equals to minus omega square minus 1. So these are the roots. So you will put x equals to minus 1 minus omega square. Just I will give you hints. Put x equals to minus 1 minus omega square star respectively and multiply. As previous, you will get alpha cube plus 1, beta cube plus 1, gamma cube plus 1 into delta cube plus 1. When you will put minus 1, you will get 4. And when you will put minus omega, you will get minus 2 omega. And when put minus omega square, you will see the value will be minus 2 omega square. So that means it will be 16 omega cube. So the value is here 16. Because since omega is imaginary cube root of unity and omega cube equals to 1. So therefore, the value of alpha cube plus 1 to beta cube plus 1 into gamma cube plus 1 into delta cube plus 1, that will be 16. Now we come to the second problem. Exercise 5a, schema of a book, the theory of equation. If alpha 1, alpha 2, alpha n be roots of the equation, be n roots of the equation, x to the power n plus nax plus b equals to 0, then prove that alpha 1 minus alpha 2, alpha 1 minus alpha 3, dot alpha 1 minus alpha n, this is equals to n alpha 1 to the power n minus 1 plus a. But how to solve this problem? In similar way as the previous problem, you can solve it. For alpha, beta, gamma, delta roots, they are alpha 1, alpha 2, alpha n roots. Since alpha 1, alpha 2, alpha n are the roots of the equation x to the power n plus nax plus b equals to 0. So we can write x to the power n plus nax plus b. This is equals to x minus alpha 1 into x minus alpha 2 multiple x minus alpha n. So obviously this is an identity in x. So now we need to think about alpha 1 minus alpha 2, this one. But okay, we'll differentiate the identity of x. So this is a polynomial function, so we can differentiate both sides. So differentiating star on the both sides with respect to x, what we will get? We will get nx to the power n minus 1 plus na. This is equals to x minus alpha 2, x minus alpha 3, x minus alpha n plus next x minus alpha 1, x minus alpha 3, x minus alpha n plus dot x minus alpha 1, x minus alpha 2, x minus alpha n minus 1. This is 2. Now we put x equals to alpha 1 on the both sides. This is also an identity. So putting x equals to alpha 1, this is double star. In double star on the both sides, what we get? So here we get n alpha 1 to the power n minus 1 plus na. So that means we just take common n. So that a equals to alpha 1 minus alpha 2, alpha 1 minus alpha 3, dot alpha 1 minus alpha n. All the term, this term is 0, here this term is 0. That means all the term are vanishes. So remaining term are basically vanishes. So that means we proved it. Thank you so much.